Bismillahirrahmanirrahim. In this lecture, we are solving problem 2 related to vapor compression cycle from the course HVAC, heating, ventilation and air conditioning. So, this is the vapor compression cycle. This is the end of evaporator. This one is the end of evaporator, and in this one the refrigerant R22 is a saturated vapor, saturated vapor, and this from 1 to 2 this is compression, and from 2 to 3 this is evaporation. This one is saturated liquid. This is saturated liquid. This one is a saturated liquid, and if we further cool in condenser, then this will be subcooling, because this is subcooled region, liquid region or subcooled region. And from 3 to 4, or from 3 to 4 in ideal condition, this is isenthalpic expansion and expansion wall, and from 4 to 1 this is evaporation. So the problem statement is, for the vapor compression cycle shown in the figure, here temperature and evaporator TE, temperature of evaporator are T1. This is given data. T1 is given as -4 degrees centigrade, and pressure in evaporator, which is P1, is given as 0.4358 megapascal, and 1 megapascal is equal to 10 bar. So multiply this by 10, so this will be equal to 4.358 bar. And temperature in condenser TC is given as 40 degrees centigrade, and this is equal to T2. And pressure in condenser, which is P2, which is equal to 1.5335 megapascal, and in bar this will be equal to 15.335 bar. 15.335 bar. Now at point A, determine the refrigeration effect. Refrigeration effect at point A, refrigeration effect is required. And B, for the same temperature, if the liquid is subcooled by 5 degrees C, there is subcooling by 5 degrees centigrade. Then find increase in refrigeration effect. And number C, from 4 to 35 degrees centigrade, and take Cp is equal to 1.339, and part B, Cp is given as 1.339 kilojoule per kilogram per Kelvin per R22. And for C part is, for the same condenser pressure, if the evaporator pressure drops from PE to 0.4358 to PE 0.4007, pressure drops to 0.4072 megapascal, which is equal to 4.072 bar. Then find refrigeration effect. It means that in 3 parts refrigeration effect is required. In first part, when there is no subcooling, then find refrigeration effect. In part B, if subcooling is up to 5 degrees centigrade, that find refrigeration effect and increase in refrigeration effect. And at part C, if pressure in evaporator is dropped and pressure in evaporator is same, so find refrigeration effect. So first we find part A. So at part A, for refrigeration effect we have to find H1 and H3. This is H1. So H1, the properties are saturated, so H1 is equal to Hg. And H3, at H3 the property are saturated liquid, so H3 will be equal to Hf. So from Cp Aurora use saturated steam table. So at state 1, from saturated saturated table of R22 refrigerant given at the end of CP Aurora book at pressure P1, pressure of evaporator, which is equal to 4.358 bar. Find H1. So Hg is equal to H1 is equal to 403.89 kilojoule per kilogram. And at state 3, from saturated table of R22 refrigerant given at the end of CP Aurora, H3 is equal to HF is equal to H3 is equal to 249.08 kilojoule per kilo. And as we know that from 3 to 4 asymptotic process, so H3 will be equal to H4. So we can find now refrigeration effect at for A. So refrigeration effect is equal to H1 minus H4 or H1 minus H3. So H1 is equal to 403.89 kilojoule per kilogram minus H4 is equal to 249.08 kilojoule per kilogram. So refrigeration effect is equal to 154.81 kilojoule per kilogram. Now for part B, there is subcooling from this point up to some point, subcooling of 5 degrees centigrade means from 40 degree to 35 degrees centigrade. So for part B, there is subcooling from 40 degree centigrade to 35, means total subcooling is 5 degree centigrade. So subcooling is 40 degree centigrade minus 35 degree centigrade is equal to 5, and we can write this difference as 5 Kelvin. We can write as 5 Kelvin, which is equal to del T. So for change in enthalpy is equal to Cp del T. Cp is specific heat constant at constant pressure. So Cp is given to us for R22, which is 1.339 kilojoule per kilogram per Kelvin, and del T is 5 Kelvin. So Kelvin will be cancelled with Kelvin, and del H is equal to 6.695 kilojoule per kg. So this is the increase in cooling. This is the change in enthalpy. Now we can find refrigeration effect at subcooling. H1. Now we find H4 dash. H4 is already given to us, but H4 dash is equal to H4 minus del H. This is the decrease in enthalpy. H4 minus del H, which is equal to 249.08 kilojoule per kg minus 6.695. So H4 dash is equal to 242.385 kilojoule per kg, and this H4 dash on diagram this point is H4 dash. This is H4 dash. So enthalpy is less, H4 dash is less than H4, so which is equal to 242.385. Now refrigeration effect is H1 minus H4 dash. So refrigeration effect of subcooling is H1 is equal to 403.89 kilojoule per kg minus H4 dash is 242.385 kilojoule per kg. So refrigeration effect after subcooling is equal to 161.505 kilojoule per kg. Now refrigeration effect is increases from 154 to 161. Now increase in refrigeration effect is equal to refrigeration effect after subcooling minus refrigeration effect with no subcooling. So refrigeration effect after subcooling is 161.505 kilojoule per kg minus refrigeration effect with no subcooling is equal to 154.81 kilojoule per kg. So increase in refrigeration effect is equal to 6.695 kilojoule per kg. This is part B. Now we are solve part C. So at part C, the evaporation expression has been dropped to P1 or P is equal to 4.072, drop to 4.072 bar or 0.472 megapascal. So convert megapascal into bar. So from saturated table of R22 given in the CP Arora book, at pressure is equal to 4.072 bar. H1 dash, find H1 dash, which is equal to 403.14 kilojoule per kg. So now refrigeration effect is equal to H1 dash minus H4. H1 dash minus H4. H1 dash is equal to 403.14 kilojoule per kg minus 249.08 kilojoule per kg. So refrigeration effect in this case, when we decrease evaporator pressure, is equal to 154.06 kilojoule per kg. So in this case, refrigeration effect is decreases. So the problem is solved. And for more video, please like and subscribe my YouTube channel. Thank you.